welcome to Space with Sarah. When I go out into the world and tell people that I'm an astrophysicist, I often get a ton of really interesting questions. Today we're going to talk about when an Earth-like planet could have formed. Many people, myself included, seem really fascinated by the idea of life elsewhere in the universe. The enormous amount of stars, galaxies, and planets that exist almost makes it weird to think that there wouldn't be life elsewhere. And also, why would we here on Earth be so special and be the only life that exists in the entire universe? One of the really interesting discoveries in astronomy within the last 20 years is that we're finding more and more planets around other stars than the Sun. We call these extrasolar planets, or exoplanets. For life to exist, there are a lot of different variables that we need to investigate. For example, does the planet that we found have a rocky surface so that we could live on it? Is it far enough from its sun to have liquid water? And also, does it have an atmosphere? A big problem in the search for life is that we don't know the probability of life starting if the conditions are there for life to start. In other words, biologists have never been able to create life out of non-life in a laboratory. These are all a lot of unknowns, and when we consider life elsewhere, intelligent life would be a lot more interesting to find. A question I like to think about is, at what point in time in the history of the universe could a planet like Earth have formed? Our own solar system is only 4.6 billion years old, but the universe is a lot older. It's 13.8 billion years old. However, the Big Bang mostly produced hydrogen and helium and only traces of a few of the heavier elements. As we would have a really hard time living on a gaseous planet, that raises the question of at what point in time in the history of the universe did we have enough elements such as oxygen, silicon, and iron, which are the majority of the elements that make up Earth's crust. Here's the crazy part. These elements need to be produced in the interiors of stars through fusion. And not only that, these stars need to actually explode or die to expel all these elements out into space. This is a whole other subject, which I'll discuss a lot more in a future video. But the point here is that Earth could not have formed until enough stars in the universe had already exploded. This means that everything we touch here on Earth, everything we're made of, is made either in the Big Bang, in the core of a star, or in a stellar explosion. As more time passes after the Big Bang, more and more stars will have had the time to explode and put out their elements. Research definitely shows that there's a correlation between the time passed since the Big Bang and the amount of heavier elements out there in space. The planet-hunting Kepler telescope has found more than 2,000 planets orbiting other stars than our Sun. And my favorite system that it's found so far consists of a star with 5 rocky planets orbiting it. The reason that I really like this system is because it's 6.6 billion years older than our own solar system, meaning that it formed only 2.6 billion years after the Big Bang. These 5 rocky planets probably don't have life because they're way too close to their host star. That means it would be really hot on their surface. However, this demonstrates that planetary systems could have formed a lot earlier in the history of the universe than our own solar system. Say for a moment that a planetary system did exist that is just as old where the conditions for life were there. That begs the question, how intelligent would their civilization be if they had evolved for billions of years longer than life here on Earth? We don't actually know the answer to that question, but it's still fascinating to think about, right? Thanks for watching Space with Sarah. If you're still curious about the universe, please subscribe to the channel, and as always, keep wondering.